For e-learning, we're gonna cut out some of what we were gonna do the day before our snow day. So this was the worksheet, and we're gonna use it as your notes instead. So if you don't have a printer, you're gonna use just regular notebook paper to jot this all down. So the thing that we missed is something called transformations. And we weren't gonna dive too deep into this because I still like us to use the tables like we did on Thursday. But for transformations, when we're graphing exponential functions, there was something that we were doing every time we added a column to our table, and we were transforming something called the parent graph. So here is the function for an exponential. The h value that's up in the exponent is the horizontal shift, and we didn't do those on Thursday. But positive means we're going left, and negative is right. The k value was us actually going up or down, so that was our vertical shift, and we were adding or subtracting at the very end. When the a was negative, we didn't really see this, but it is a reflection, which means it's going to be upside down. And that happens over the x-axis. If a is greater than 1, so the front number, it was a stretch. And if it's less than, it was it's a compression. And remember, if a is greater than 1, it's a growth. And if it was less than, it was a decay. So just looking at number 2, the a value is what is in front. So that 2, it's greater than 1. So this is a vertical stretch. Oops. It is a +1 on the back, so then it is a vertical shift up 1. I skipped number 1. Whoops. Oh no, there was no number 1. That was just in the table. Okay, number 3 has a negative value in front, so that is a reflection. It has a -2 in the exponent, so if it's x minus 2, it's going to be horizontal, and that means it's the opposite, so it's going right 2. And then number 4, I never have you graph something like number 4, but here's a lot of things going on. We have a negative in the front, so it's a reflection. We have 1/3 as your a value, so that is going to be a vertical compression. And I should probably put the 1/3 there, and I probably should have put the stretch of 2 over there. So it's a vertical compression. Let's see, next you have a +1 in your exponent, so that is telling you to go left 1 because you go the opposite. And then lastly, it's -3, so it's down 3. So that would be a pretty big table if we had to graph that. The next part, just going back to good old review with graphing. So on Thursday we made a table for this. What did we do? We had -2, -1, 0, 1, 2, and those were always our x values. We had our exponent to the function first, so 2 to the x. And then we were going to add 1 at the end because we were following order of operations and doing our exponent first, then followed by addition. So that 2 to the x is technically like the parent function. And this +1 is telling you what our transformation is. So if it's +1, you guys were already doing transformations. We just weren't necessarily like explicitly talking about it. It's going up 1. So we still do our table normally. So 2 to the -1 is 2 to the negative 2 is 1/4, and we just used our calculator for that. We added 1, and that's 1 1/4. 2 to the negative 1 is 1/2. Add 1 is 1 1/2. 2 to the 0 is 1. Add 1 is 2. So clearly things are getting bigger. 2 plus 1 is 3. 2 squared we know is 4. And that's going to give us 5. So then we just went over to our graph on Thursday and plotted our x and our y values the best that we could to show our exponential growth. Negative 1, 1 1/2. And then I talked about it in the warm-up on Thursday, but I didn't really dive too much into the asymptote. But the asymptote is a line that's never going to cross, and that is also a transformation. So if you have an up-down transformation, that is your asymptote. So my graph is actually never going to cross 1. It's never going to cross 1 because it's right there as +1. It's in my table as +1. That's my transformation, so it's never going to cross y equals 1. And then domain and range we're not going to worry about. Let's go ahead and do 6. 6 again, make your table. 2, negative 1, 0, 1, 2. We have 1/4 the power of x. The 3 in the front is the a value, and it's being multiplied, so we're timesing by 3. If my a value is greater than 1, I have a vertical stretch by 3. There is no number back here, so that would mean my asymptote is probably going to be at 0, but we'll make sure when we go ahead and graph this. So we have 1/4, and remember if you're using your calculator you need to use parentheses, to the negative 2, which is 16 times 3, which is hopefully 48. And then we have 1/4 to the negative 1, which is 4, times 3 is 12. 1/4 to the 0 is 1, times 3 is 3. And you guys are catching the drift here. 1/4, 3 times 1/4 is 3/4. 1/4 squared is 1/16. Times 3 is 3/16. Alright, so that vertical stretch by 3 is making our graph crazy, right? It went 48, dropped to 12, to 3, 3/4, 3/16. So when you're having a vertical stretch, you're having like a huge exponential growth or decay. So I'm going to go ahead and do the best I can to graph this. Negative 2, 48 clearly does not fit on my graph, but I can do negative 1, 12. 0, 3, 1 and 3/4. Oh my gosh. And 2, 3/16. Not make my dot on my, okay. Connect your dots, or your points. And my asymptote, I didn't have an up-down shift at all. So my asymptote is definitely at 0. And again, we're not going to worry about domain or range. So the transformation is just kind of confirming what your table was already telling us. There's nothing too fancy about it. 7, we're not going to graph, but the transformation would be a negative so it's a reflection. And it's a +3, so that would be up 3. So then right away, that would be your asymptote. 8. Now we have an exponent that has a shift. So if it's x minus 2, you're going to do the opposite, which means you're going to go right 2. So when I would make my table for this, I still have my -2, -1, 0, 1, 2. We're going to need a little bit more room for our table now because it's 1/2 x minus 2. So I'm going to try to write this a little neater. Alright, so we have 1/2. How much writing neat? That's going to be -2 minus 2, because I'm taking my -2 and plugging it in for that x, which equals 1/2 to the -4. And 1/2 to the -4 is 16. Then we do 1/2. -1 minus 2 is 1/2 to the -3, which is 8. 1/2, 0 minus 1. Oh, I'm sorry, 2 is 1/2 to the -1, which is 2. 1/2, 1 minus 2. Oh my gosh, I just did that wrong. (1/2) 0 minus 2 is -2. 1/2 to the -2 is 4. Now, this is the next answer. 1/2, 1 minus 2 is -1, which is 2. And then 1/2, 2 minus 2 is finally 0, so that's giving us 1. So we're going to end up just shifting our graph to the right by 2, and that's all that exponent change does. So if it's -2, 16, that doesn't fit. -1, 8 does. 0, 4, 1, 2, and lastly 2, 1. There is no up or down shift, so your asymptote is still at 0. And we would have seen that if we kept going with our table. But the big thing for today, and we will review this on Monday before we take your test, is identifying the transformations. We're still going to graph using our tables. It's just kind of showing you why you're making an extra column. It's just further explaining what you're doing. And you'll do that a lot more in Algebra 2 and Pre-Cal when you get to your higher level math classes. So this is just a really quick introduction into transformations with exponential graphs. But other than that, you're going to do your tables. I have a minute left. The last thing is, if you have me first or second hour, I have to administer iStep on Thursday and Friday. So that means you need to stop by my room Thursday and Friday morning to pick up any paper materials that you might need while you're in the cafeteria, because you will not be coming to class. 4th hour, 6th hour, I will see you. But my first and second hours, you'll need to get all of the notes, copies, and everything, worksheets from me the morning before school starts. Happy learning, and I'll see some of you Thursday, and some other of you I will see when I see. Bye, guys.